Good evening, everybody, and thank you for joining us for the Institute of Food and Health Public Lecture Series. This is the first of 2023, and you're all very welcome. And this lecture series is designed to provide you with most up-to-date scientific knowledge in an area in food and health of interest to the public. This evening is the very important topic of nutrition for healthy aging, and I'm delighted to welcome our speaker, Professor Helen Roche. So Helen is a professor of nutrition and she specializes in nutrigenomics. And this focuses on the mechanisms that underpin the health effects of nutrition and food intake. Helen is the director of the UCD Conway Institute, and she leads the nutrigenomics team, who have conducted several projects in the area of healthy aging. And she'll share some of this research with us this evening. Her team are very involved in optimizing immune training, which can be disturbed in conditions such as obesity and non-alcoholic fatty liver disease, and as a consequence of increased aging. So Helen initially trained in dietetics, and now she combines her clinical insights with mechanistic understandings, advancing our knowledge of diet and health. And I say tonight, particularly in the area of aging. Now, an important part of this lecture series is providing you, the public, an opportunity to ask some burning questions that you may have, either coming to the talk or as a result of what you may learn from the talk this evening. So Professor Helen Roche will be joined by Professor Claire Roche. So Claire is a dietitian and also an academic here at University College Dublin, and she leads the UCD Masters in Clinical Nutrition and Dietetics programme. Most of her research is in the area of nutrition and older adults, and she has participated in many national and European projects looking at best practice in screening and managing poor nutrition in older people. So Claire is very active in a number of public bodies, active in the Nutrition Society, the Irish Nutrition and Dietetic Institute, and contributes to research and practice to enhance the health of older people, both nationally and internationally. So during the course of the talk, you can put your questions in the question and answer tab that you'll have in your Zoom function. And the questions at the end will be moderated by my colleague, Professor Lorraine Brennan. So we look forward to hearing the questions that you may have to pose. So I'm delighted to welcome Helen, and over to you now. Thank you very much.
Great. Thanks very much, Dolores. And good evening, everyone, and Happy New Year. Thank you very much for taking the time to join us. And as Dolores said, we're more than happy to ask any questions, either if I don't explain something quite correctly, or indeed if you've got something else that is of interest to you. And within the context of nutrition for healthy aging, what I was hoping to focus on was two main areas. The first of which is sarcopenia, which is the loss of skeletal mass, which happens with age. And then a teeny little bit in relation to immune training. And I'll explain to you the role of food and nutrition. And within the context of that and lifestyle, even though I'm coming from the nutrition perspective, it really does need to be acknowledged that lifestyle elements, particularly physical activity, are just as important and indeed work in synergy. So over the life cycle, our nutritional needs, they change over time to meet the demands of different stages of growth and repair, which happen at different stages of our life. And essentially, as we get older, and by I mean older, I mean after nearly 25 years of age, that rate of growth and repair, or what we refer to as turnover, declines. And that leads to a number of age-related conditions. And indeed, anything is age-related these days. We could be talking about diabetes or heart disease, but today I just thought I'd speak about sarcopenia and what we call immunosenescence. At UCD, we've got a particular interest in the whole area of precision nutrition. When I trained in dietetics, it was, one diet for one person, or for everyone, as it were. Whereas now we really do focus on trying to define the right dietary patterns in combination with different lifestyle elements for the right person at the right time. Because within any given population, you will always have certain groups or subgroups who may need specific interventions, say with protein, or would be more responsive to physical interventions. And we're trying to build up that knowledge base. Data from the UN demonstrates that essentially our world is becoming older by the year, and this shows the increase in both the global and the European population and how it will grow until the next century. And in terms of putting some numbers on that, essentially 850 million people will celebrate their 65th birthday very soon. And over 65s will account for more than 16% of the population by 2050. So that means we're going to have an almost greater proportion of the population, nearly 2 times the number of older adults that we will have of younger children under the age 5. In terms of Europe, our older adult population is going to grow from, it's now about 20%. Or 22%, and it's going to grow up to 30% within the next few decades. And this is within the context of the global population not necessarily getting any bigger. So it's the proportion of individuals who will increase in age. And with that, it is very important that we keep that population as healthy as possible to sort of delay the onset of natural conditions that are going to emerge over that time. So this just is a graphic which essentially illustrates that. And you can see on the top left-hand corner that essentially in, I think that was 2019, you had a very small proportion of the population who were older. And as you move to 2022 and indeed 2050, which is down on the left-hand, bottom left-hand corner, you can see that proportion or number of individuals who will go into that older age category will increase. So it's really important that we address this stage of life in a very proactive way. As I said, everything is age-related, and I had to sort of drill down and focus on 2 key issues. And those 2 key issues are sarcopenia and osteoporosis. Of course, another day we could talk about obesity, type 2 diabetes, or cardiovascular disease. But today we're going to focus specifically on dietary protein and some of the micronutrients who work with protein in terms of attenuating the rate of skeletal muscle mass loss, and also immune training, which is a little bit of work in progress that we're learning about. And as I said previously, nutrition goes hand in hand with lifestyle and particularly physical activity. So this little cartoon essentially demonstrates what sarcopenia is. It's the loss of both skeletal muscle mass, but also strength with age. And all of us acquire our peak skeletal muscle mass and strength at about 25 to 30 years of age. That's a result of growth hormone being present in the body. And then after that, there's a gradual decline. And until the age of 40, the levels stay pretty high. But between 40 and 50, there's a progressive loss of about 8% per decade. And then after 70, that rate of skeletal muscle loss again accentuates. Now, in terms of thinking about aging, there's always chronological or biological age, which is the number of years you are. And there's also biological age. And that's why nutrition and lifestyle is very important, because lifestyle factors and your environment do have a potential big impact in terms of health. Now, aging is inevitable, but you can sort of keep yourself fit and try to keep yourself as healthy as possible with a little bit of good luck as well. But it's important to appreciate that our energy intake and also our energy requirements decline with age. But interestingly, the nutrient requirements stay about the same. Now, you may hear in the public media that, oh, you know, fasting and energy restriction, it may promote longevity. A lot of that research is based on animal models, and it doesn't really translate that clearly to man. And indeed, from my perspective, if you were going to take one message away with you this evening, I would say that, you know, with age, it's a matter of eating better, but not less, maybe more desirable. And what this slide illustrates is that essentially our energy intake, and this is of US males and females, peaks at about 2025 in both males and females. And then our energy intake, because our requirements go down, they also go down. And that's a natural part of the body because our energy requirements just attenuate with time. However, as I said, our nutrient needs remain very high. So it's really important to think about quality over quantity. So this little cartoon just again gets across the idea that over time, our percent total of lean muscle mass and strength declines with age. Now, it's very easy to see the decline in muscle mass. You might see, when your legs are getting a little bit thinner or, whatever. And after the age of 50, you essentially lose 1% of skeletal muscle mass per year. Now, that's what you can see. But what is important about sarcopenia is that it envelops both the mass of muscle, but also the strength of muscle. And indeed, the strength element does decline at a greater rate with time, unless you bring in physical activity. For example, between 50 and 60 years of age, you lose about 1.5% per year. And after the age of 60, that is accentuated more or doubles to about 3%. And of course, that's going to be impacted by other comorbidities. For example, if you have rheumatoid arthritis, your joints are going to be slower or sore. And if you get any sort of infection, you may just have to go to bed for a little while, but all those periods of inactivity will actually extenuate that time. And even though physical activity may be not the most comfortable, it does have a very strong beneficial effect. Indeed, there's nothing like a picture. So these slides represent the cross-section of somebody's thigh. And the thigh of the young person is a male. He's 24 years of age, and he weighs 75 kilos. Now, those 75 kilos are composed of 10 kilos of fat or adipose tissue and about 57 kilos of lean mass. Now, an equally heavy man who's 66, you can see the lean mass in the middle is much less. Indeed, even though he's 81 kilos, his fat-free mass has reduced from 50-something kilos to 13 kilos. And that's because a lot of our tissues transform from being lean mass to fat mass as a natural part of aging. However, this is an older sedentary man. If you look at the cross-section of the thigh of an equally aged man who's pretty much the same weight, and he's physically active, and you're talking physical activity of about 13,000 steps per day. And he is a much greater, you can see the skeletal mass that is there. So that really just illustrates what happens when you are more active and make that conscious effort to remain more active. And of course, you have to provide the body with the nutrients to synthesize and to make that skeletal muscle, because our muscles are turning over all the time. So now I'll switch a little bit to the nutrition element. But before I do, when I trained in dietetics, it was very easy in a way to see sarcopenia. But now we don't see it necessarily, because I guess you expect to see somebody who's wasted muscles, but individuals who are carrying extra weight and even a little bit of extra weight, sarcopenia may not be naturally evident. So, clinically and also from a public health perspective, we have to be a little bit more cognizant of that balance between fat mass and lean mass. One of the reasons, or there are several reasons why we should be thinking about sarcopenia, is because essentially if you lose that skeletal muscle strength, you become frailer at a much greater rate. There's a greater chance, I don't mean to be morbid and depressing, but there's a greater chance of falling. There's a greater chance of having other comorbidities which come with that frailty. So it's really important. In terms of what causes sarcopenia, yes, it is a natural function of age. However, there's one key process, and that is known as muscle proteins turnover. And I'm going to explain this a little bit to you so that you can understand the basis of some of the recommendations. And both nutrition and physical activity interact and determine that rate of turnover. So there are a couple of things which lead to age-related poor protein status. The first of which, of course, if you don't eat enough protein, then you don't have enough of the building blocks in order to replace that skeletal muscle. And that can happen as a result of what's known as the anorexia of aging, when you literally just lose your appetite because your sense of taste and sense of smell declines. Also with age, and this is particularly 65 plus, you can lose the ability to use the available protein to its maximal effect. And this is known as something known as anabolic resistance. So anabolism means it's the ability to build up an organ. Or indeed, you may have greater protein requirements because you may have an underlying condition. You may have survived cancer. You may have an inflammatory condition. And in all of these conditions, we would then recommend not just 0.8 grams per kilogram of protein per day, but maybe 1 or 1.2. And it can be a combination of all of these, which leads to a loss of functionality, either in terms of muscle, which I'll talk about, and also the immune system. So maybe there's a simple message: you just eat more protein. And that sort of is the case, but it's a teeny bit more complicated. And so I thought I would explain some of the nuances so you would appreciate ways in which you may be able to step around this challenge. So there is a very close relationship between habitual protein intake and also the rate at which individuals may or may not lose skeletal muscle mass. So what this graph shows essentially is that if you habitually consume a low protein diet, which would be less than 0.7 grams per kilogram per day, you will lose almost 0.6 kilograms in appendicular lean mass. So that is the main muscle mass in the body. However, if you're a high protein consumer consuming more than 1 gram per kilogram per day, that rate of loss over a 3-year period, as was measured in this study, is going to be 50% less. So that is one of the reasons why, we would promote these higher protein intakes as you get a little bit older. Now, one of the reasons why you lose this skeletal muscle mass is because there's an imbalance in the rate at which we make muscle and we degrade muscle. And we look at a key marker known as skeletal muscle protein synthesis. And it's essentially a balance that changes about 3 or 4 times in the day. And after you eat, you promote skeletal muscle protein synthesis. And when you're in the fasted state or don't consume protein, you're in the degradation stage. So just to illustrate this in a cartoon, essentially when you eat a meal, say breakfast, you induce, if it contains protein, you induce skeletal muscle protein synthesis. So your balance of protein increases. Then during the fasting state, it goes down. Then after your lunch, if it contains protein, it goes up. Fasting, again, it goes down. And dinner, which is the main meal, usually contains the most amount of protein. You induce muscle protein synthesis. So you sort of get the story. It switches on, it switches off continually over the day. So essentially you want to switch that process on, certainly twice, if not 3 times a day. But the difference between younger individuals and older individuals is the peak at which you reach skeletal muscle protein synthesis. So keep looking at the green part of the bars. When you're older, we get less of a peak as a result of consuming pretty much the same amount of protein. But there is something else you can do about it. I mentioned resistance exercise and indeed any physical activity, because with physical activity, you can actually accentuate the effect of the same amount of protein. So there are ways around things. And that's why I'm saying to you, it's both the amount of protein you consume, but also the physical activity. So just to look at some of the data that is out there. Also, I should mention that you get the maximal amount of a protein dose within the 2 hours of physical activity. So you can both make sure that you have a snack which contains protein 2 hours after resistance or even aerobic exercise. This was an interesting study which essentially demonstrated that the dose of dietary protein was key in terms of stimulating muscle protein synthesis. So on the left-hand side here, we're measuring, it's called fractional synthetic rate, but we're measuring the rate of muscle protein synthesis. So if you're a young man and you consume no protein, that rate of synthesis is going to be down. And in response to either 10 grams, 20 grams, or 40 grams, you can see that you get this almost linear increase in protein synthesis. However, if you're in an older age group, as in over 65, you don't get the same impact of that 10 grams of protein. You do get a significant increase with 20 grams, but really you need 40 grams to attain what a younger person would get out of the 30 grams. And so this is this anabolic resistance. And so we need a couple of tricks to get around this problem. So one easy trick is just to eat plenty of protein. But as you will see, 30 to 40 grams of protein to be consumed 2 or 3 times a day is actually quite a lot. And that can be a lot, especially if your appetite is poor or if you're older and, essentially you don't have the same appetite that you used to have. But just to give you an idea of how much protein you need to induce muscle protein synthesis, you're talking about 3/4 of a chicken fillet. You're talking about 3/4 of a litre of milk. 2 fairly decent sized small bowls of yogurt, beans, and 5 eggs. So it's a fair amount. So in nutrition, we have discovered, and certainly a guy called Luc van Loon has done a huge amount of work. He's based in Maastricht. But you can enrich the diet with one particular amino acid, and that's known as leucine. Leucine is branched chain amino acid. The natural food sources are coming from whey, which is a protein present in dairy foods. So that would include milk, cheese, yogurts. It's also present in the meats, but the dairy elements essentially are richer. And by supplementing diets with leucine, it has been demonstrated that you not only improve muscle protein synthesis because you increase the protein dose, but it actually has a unique stimulating effect on muscle protein synthesis. And indeed, former colleague, Keelan Murphy, trained initially as a dietitian, and she did her PhD in McMaster in Canada, where she did some of this work. And she then came back over to UCD. And she did some very nice work, which essentially demonstrated that leucine supplementation in combination with resistance exercise can be very effective at bumping up these levels of the important amino acids and in turn inducing muscle protein synthesis. And I'll just show you some of this here. So what she did was, with older men, they either ate a low protein diet, which contained 0.8 grams per kilogram per day, or a high protein diet. And then she put a leucine dose into the meals. So irrespective of whether you were on an LP or a low protein diet, when leucine was added in there, which is the open squares, or if you were on a high protein diet, which is the open triangles, you got this peak in leucine levels following those meals. And the meals are indicated with the arrows along the timeline. And what happened once we reached those peaks of the leucine was there was an increase in muscle protein synthesis. That increase happened to a greater extent following the high protein diet in the rested state. However, you can see she also measured it post-exercise. And post-exercise, you see that you get a much greater boost as a result of consuming the leucine as well as the physical activity with respect to the fractional synthetic rate, or the rate at which you synthesize your muscles. There are a couple of other nutrients which have been looked at to see if they work synergistically with the amino acids. Some are long-chain N3 PUFAs, or you might know them as fish oil, or omega-3s, and also vitamin D. And that data is a little bit mixed. And by mixed, I mean in some studies it works, and then in other studies it doesn't work. And it's not that one study is right or wrong. There were important nuances between either the populations that were studied or the way they measured the muscle protein synthesis, which probably explains the diversity in results. And that's why we're interested in precision nutrition, because in some contexts things work and in other times they do not. And it's as important to be able to demonstrate something doesn't work as it does. So for example, this study was done to investigate the impact of long-chain N3 PUFAs, or fish oils, and it demonstrated that by supplementing with omega-3s in the acute feeding state, you could enhance the impact of leucine with respect to muscle protein synthesis. And indeed, it was demonstrated in another study that long-chain N3 PUFA improved muscle gain, or isometric peak torque, which is a measure of skeletal muscle strength, in women, but not men, which again, we don't know the basis for this, but they're the results. And it may be due to the fact that there was a greater variation or diversity within the male group, which is on the left. You can see that the error bars are bigger, whereas women, because they've got a smaller skeletal mass, they may have got more bang for their buck as a result of the long-chain N3 PUFA, and also their responses are much tighter, which reflects their basal level of skeletal muscle mass. Now, Keelan conducted a study here with us at UCD. It was called Nutri-malt, and it was to look at novel nutritional interventions in individuals at risk of sarcopenia. And I thought that some of our participants might actually have logged on. So I thought I would present some of the work, and I'd like to thank Keelan very much for doing this work and leading the program. So essentially, Nutri-malt was a randomized controlled trial we had over 100 participants who were all at risk of sarcopenia. So what I mean by at risk of sarcopenia means that they had a degree of less skeletal muscle mass, as well as a degree of weakness in their muscles. And they were randomly assigned to receive either a placebo, which is the control, or a supplement which contained leucine, or another supplement which contained glucine plus long-chain N3 PUFAs. And essentially, we were trying to figure out whether there were synergistic effects between the leucine and the long-chain N3 PUFA. As you will see, that these individuals, we had 30-something in each group, and most of the individuals, they were in their early 70s. They had a body mass of about 70 kilos, and a BMI of 24, 25. So otherwise fit and healthy. Now, when we gave these subjects the supplements for 6 months, and we measured a number of biometrics, which would include appendicular lean muscle mass, your knee extension strength, but unfortunately, we did not see a significant effect of the leucine or the long-chain N3 PUFA supplementation. And of course, after going through all of this effort, it was very disappointing. But essentially, when we went back to look at the habitual diet of our participants, who we recruited very carefully to make sure that they all had sarcopenia or were at risk of sarcopenia, with 2020 hindsight, it was very evident that that cohort were well nourished, as in their habitual protein intake was approximately 1.1, 1.2. And indeed, with some retrospective analysis, we've been able to demonstrate that essentially we would have got it's probable that we would have got more beneficial impacts of both the leucine and the long-chain N3 PUFA if we had specifically recruited individuals with sarcopenia as well as suboptimal protein status. But all was not lost, because we also looked at a number of markers of cardiometabolic health. And I did this in collaboration with my colleague, Lorraine Brennan. And essentially, we measured a number of metabolites in the blood after these individuals following the study. And those subjects who received the supplement with the long-chain N3 PUFA, there was a very significant reduction in the amount of lactate in their blood. Also, the level of VLDLs, which are the very low density lipoproteins, which carry both triglycerides and cholesterol in your blood. So, and also we increased the amount of long-chain N3 PUFA in their circulation. So those were the beneficial effects, even though we did not see the direct effect with respect to skeletal muscle mass. More recently, we've been doing a lot of work on plant-based proteins. And this has been a very interesting study. And, plant-based diets are very topical. There's a lot in the media in relation to them. And, essentially from a biological perspective, we're trying to figure out which ones are the best, how do they work, what sort of combinations are best, because of course, in terms of the carbon footprint, they are more environmentally friendly. So this was part of a European study, and a lovely PhD student, Elena DeMarco Castro, she completed part of this study together with colleagues in Italy. So essentially in the first phase, we were looking at the composition and different blends of plant proteins. So we made 3 different cocktails, as it were. One was composed of pea and pumpkin. The second was composed of pea, oat, and almond, because of course nuts contain a good amount of protein. And then the third was pea, soya, and rice. And in vitro, which means in an experimental model, when we measured the in vitro digestibility of these proteins, they all worked equivalently the same and worked as good as the gold standard, which is whey. However, when we fed these plant protein combinations, the profile that we saw in the plasma was different to what we expected. So essentially, this represents the concentration of both leucine and the total branched chain amino acids, which increase in concentration when when these individuals consumed a meal which contained exactly the same amount of leucine in each of the 4 meals. However, you can see in the black, which is the whey, that increased to a maximal level of, say, 300 nanomolar. However, even though the plant protein products contained the same amount of leucine, we got approximately 50% of the peak. And as a result of this would mean that those plant protein sort of test meals would not be as beneficial as it were with muscle protein synthesis. So we're continuing on this work, and we're figuring out with other tricks and tools to see whether we can improve the bioefficacy of such plant protein elements. So it's preliminary data, but it's very important. And it's really important to bring this new knowledge to the table in terms of understanding the relationship between diet and health. I'll just take a moment now and talk a little bit about nutrition and immune function. I won't talk about this too long because we did a public lecture in relation to this approximately 2 years ago. But within the context of healthy aging, it is also very important to acknowledge that your immune system does tend to wane, and specifically your innate or your natural immune system. This is the immune system which is your first line of defense, either in relation to, say, viruses, which we know very well about. And then also that immune system can sometimes become overactive or hyperactive, say, for example, rheumatoid arthritis. So my team does a lot of work in terms of immunosenescence and trying to understand how we can either bump up the immune response or pull it back if it's the case that it's hyperinflammatory. And what's important is that there's such a thing as training your immune system. And I'm not going to talk about this at length, but it's very important to appreciate that your innate immune system has a memory. It remembers what you ate over the last number of years. And if you ate a very high fat diet, which is particularly rich in saturated fat, your immune system is going to be primed and is going to be more pro-inflammatory. And that's not necessarily a good thing. So going forward, perhaps just try to avoid those saturated fats and try to pull back your immune response. But equally, it is possible to promote the resolving arm of the immune response. And as I said, we're now working more in the immunosenescence space to see whether both physical activity and also dietary interventions may be able to bump up and attenuate this process. As I said to you at the start, within the context of skeletal muscle health, exercise is just as important as nutrition. Well, believe it or not, a number of groups based both in Norway and Sweden have done beautiful work, which have demonstrated that actually physical activity also keeps your immune system fit and healthy. And I would be advocating protein and also a lot of vitamins and minerals in terms of keeping your immune system, fit and healthy, so that you're able to fight off any of those infections. And the reasons why I would be promoting protein is because protein supplies the amino acids, which are the building blocks for all the immune proteins, which actually help you fight an infection. And also it's very important to appreciate that a lot of the vitamins and minerals such as zinc, vitamin A, selenium, and vitamin D, they work as cofactors to essentially make sure that the enzymes which regulate both the immune response to protect you and also the inflammatory response, you need adequate amount of those as well. So again, it's going back to the whole theme of dietary quality. And as I show here in a pictogram, as it were, those protein sources, which we would be advocating, are also an excellent source of key minerals, vitamins that you require to keep your immune system in the optimal fashion. Because essentially you want to keep your optimal nutrition status and stores for the day that you will get an infection or the day you will have an inflammatory response, so that you can keep that immune system in check and hopefully maintain good protection and defense. Before I wrap up, I wanted to share with you a new exciting study that we're doing. Again, it's another European study, and this time we're focusing on appetite. And one of the reasons for that was because we'd done Nutri-malt, we learned an awful lot in relation to that. And we learned in relation to, you really need to get into intervening with individuals before they become malnourished. So I thought, well, why don't we focus on appetite? And one of my colleagues, Katie Horner, is a specialist in appetite, and we're working together to see whether or not we can look at interactions between protein and fiber. And the reason why we're looking into that is because on one hand, you need a lot of protein to prevent malnutrition, to prevent frailty, and to prevent sarcopenia. But acute studies show that high protein intake actually promotes satiety. So it's a little bit of a catch-22. But even though that catch-22 is out there, there's been a lot of work done in younger individuals, but we don't really know how protein combinations with fiber will actually integrate and affect appetite in older persons. So we're going to do this intervention study, which will look at the impact of both proteins, particularly plant proteins and fiber, with and without physical activity. And we'll look at a whole range of biomarkers such as appetite, so measure it using biomarkers, which we have optimized here, and also other health outcomes, including immune function. And essentially, we're one of 4 centres across Europe. And in Dublin, we're recruiting 60 individuals who are 65 plus, otherwise healthy, but they may feel as if they're not eating as much as they might have, say, 5 years or 10 years ago. And in this study, because we learned so much from Nutri-malt, we're going to do both the plant proteins and fiber with and without the physical activity element. And that gives us the opportunity to compare the relative efficacy of the diet alone, physical activity alone, or the combination of both versus the control, which is the usual lifestyle. So if you are of this age group, if you're interested in learning more about nutrition, learning more about different exercises, and there will be exercises classes being given to you. And if you're generally interested in learning more healthy lifestyle information, do get in contact with us. And indeed, we've got a specific website. We've also got an email, and we'd be delighted to hear from you. And this is where I'm going to wrap up, really, with the food pyramid. It really is back to basics. It is so important to have those high protein levels, be it from meat, fish, poultry, pulses, lentils, etc. At least 3 servings of milk, yogurt, cheese, etc., as well as all of those fruit and veg. Because with age, yes, you don't need as many calories, but you need more of the sort of lower levels on the food pyramid. And it really is very important that you consume as many and as much of those, keeping a healthy weight. And with that, again, these are 2 nice slides from Keelan, who gave them to me. So you can see the effect of diet, but it's also physical activity, but also inactivity. And bed rest can be, particularly detrimental. And it's fine, to stay in bed for a couple of days and, indeed, if you're iller. But as soon as you can, and as soon as you feel you can be mobilized, you really should try to do your best if you can. And with that, these are a couple of resources. Healthy Ireland have a nice website. Get Ireland Active have a number of nice exercise regimes for individuals. Sports Ireland is a great resource, and also the HSE. And with that, I'll leave these details here. And I'd also like to thank my colleagues, particularly Keelan Murphy and also Anna Quinn, who give me a lot of help in relation to preparing this, the slides for this. Also, my colleague Claire Corish and Katie Horner, who worked with me on the appetite study. Previously worked with Lorraine Brennan and also Claire Connolly in relation to the Nutri-malt study. And with that, we will be delighted to answer any questions or queries. Maybe I didn't explain something properly, or you may have other queries yourself. Thanks very much.